It is 7:07 a.m. on August 25th, 79 AD. The earth trembles beneath your feet as you desperately flee through the streets of Pompeii. The morning sun has vanished, replaced by a black wall of death racing toward you at 100 miles per hour. The temperature inside the approaching pyroclastic surge reaches 500 degrees Celsius, hot enough to melt copper, and you have mere seconds to live. Your lungs burn from the superheated gases as debris pelts your body. Behind you, the mountain that your people once trusted as dormant has become a monster, unleashing energy equivalent to 100,000 atomic bombs. This is your final moment. No prayer, no escape, no tomorrow. This was the reality for thousands of souls in one of history's most devastating natural disasters. But here's the haunting question that echoes through time. With today's technology, could we have saved them all? To answer this, we must journey back to a tragedy that began not with the eruption itself, but with 17 years of missed warnings that modern science would never have ignored. The story of Pompeii isn't just about volcanic destruction, it's about a cascade of signs that whispered danger, while an entire civilization turned deaf ears to nature's warnings. Our tale begins on a cold February morning in 62 AD. The citizens of Pompeii wake to a world transformed by violence. The earth has convulsed with such fury that buildings lie in rubble. Sophisticated aqueduct systems have failed, and even the grand temple of Jupiter stands wounded against the sky. Survivors wander through streets they no longer recognize, stepping over marble fragments and broken dreams. The earthquake measures between magnitude 5 and 6, devastating, but not uncommon in this region where the earth seems perpetually restless. What the Romans couldn't understand with their limited knowledge of geology, was that this earthquake was Vesuvius clearing its throat. In the mountain's deep chambers, magma had begun its inexorable rise, fracturing rock, building pressure, sending tremors through the earth as it sought pathways to the surface. This wasn't just seismic activity, it was a 17-year countdown to catastrophe. But imagine if those trembling Romans had access to our modern understanding. Today's seismologists would have immediately recognized the earthquake's signature as volcanic in origin. Networks of sensitive instruments would have detected the distinct frequency patterns that indicate magma movement versus tectonic shifts. The USGS Volcano Hazards Program monitors volcanoes using seismometers so sensitive they can detect earthquakes too small for humans to feel, yet powerful enough to reveal a mountain's hidden intentions. Within hours of that 62 AD earthquake, emergency protocols would have activated, scientists would have swarmed the region, and Vesuvius would have been placed under intensive surveillance. Instead, the Romans rebuilt. They patched their walls, repaired their roads, and convinced themselves that the worst was over. For 17 years, minor earthquakes continued, what modern volcanologists would recognize as a classic pattern of increasing volcanic unrest. Wells mysteriously dried up as underground water channels shifted. The sophisticated Roman aqueduct system, engineered with precise gradients to carry water from the Apennine Mountains, began to fail as the ground subtly rose and fell with the breathing of the awakening volcano. Archaeological evidence reveals the mounting crisis: warped mosaic floors in homes, emergency repairs to sewage systems, septic tanks hastily filled with stones. The very infrastructure that made Roman life possible was slowly buckling under geological stress. Yet the Romans normalized these signs, dismissing them as the quirks of living in earthquake country. Pliny the Younger later wrote that such tremors were not particularly alarming because they are frequent in Campania. This fatal complacency would be impossible today, when GPS systems can detect ground movement as subtle as millimeters and satellite radar can spot deformation invisible to the naked eye. As we approach that fateful August day in 79 AD, the warning signs accelerated like a drumbeat of doom. 4 days before the eruption, earthquakes began occurring with increasing frequency. Modern monitoring would have detected this seismic crescendo and recognized it as an immediate precursor to major volcanic activity. Automatic alert systems would have begun sending warnings to every mobile device in the region. Emergency management teams would have started staging evacuation resources. the 20,000 residents of Pompeii would have known exactly what was coming and exactly what they needed to do. Instead, on the morning of August 24, 79 AD, the people of Pompeii woke to what seemed like an ordinary day. Merchants opened their shops, children played in the streets, and housewives went about their daily routines. The mountain loomed silent and seemingly peaceful in the morning light, giving no hint that in just hours it would become a force of destruction beyond their wildest nightmares. Around noon, Vesuvius shattered the tranquility with a roar that shook the earth. The eruption began with such violence that volcanic debris shot 33 kilometers into the stratosphere, creating a column visible from hundreds of miles away. Pliny the Younger, observing from across the Bay of Naples, described it as resembling a massive umbrella pine tree, rising straight up before spreading into branches of ash and pumice. But even at this late hour, with the volcano already erupting, thousands of lives could still have been saved with modern technology and understanding. The eruption didn't immediately turn deadly. It began with what volcanologists call a Plinian phase, shooting debris high into the atmosphere where winds carried it southeast toward Pompeii. For the next 18 hours, the city was pelted with pumice stones and ash, but the truly lethal phase had not yet begun. This 18-hour window represents the difference between ancient tragedy and modern survival. Today's volcanic monitoring systems can detect the exact moment an eruption begins and predict with remarkable accuracy how it will evolve. Infrared satellites would have tracked the thermal signature of the eruption column, while seismic networks would have monitored its intensity and stability. Most crucially, modern volcanologists would have known that when such a massive eruption column becomes unstable, it collapses. And when it collapses, it creates pyroclastic flows. Modern emergency management systems routinely evacuate hundreds of thousands of people from disaster zones within hours. Using real-time traffic modeling, GPS routing, and coordinated transportation networks, evacuation specialists can calculate optimal routes and staging areas to move large populations efficiently. The residents of Pompeii, with 18 hours of warning, could have been shepherded to safety long before the mountain unleashed its true fury. Instead, as ash and pumice rained down through the afternoon and evening, many Pompeians made a fateful decision to shelter in place. Some fled immediately, but others, perhaps trusting that the worst was over, perhaps unable to abandon their homes and possessions, hunkered down to wait out what they hoped was a temporary crisis. The weight of accumulating volcanic debris began collapsing roofs, claiming the first victims of the disaster. Those who stayed behind had no way of knowing they were living through the calm before an unimaginable storm. As midnight approached on August 25th, the nature of the eruption changed with catastrophic suddenness. The towering column of debris, now stretching 20 miles into the sky, could no longer support its own massive weight. Like a skyscraper built of ash and gas, it began to collapse, sending superheated avalanches of rock and gas racing down the mountainside at speeds exceeding 100 miles per hour. The first pyroclastic flow struck Herculaneum, the wealthy seaside resort town on Vesuvius's western flank. The residents who had remained behind, perhaps 400 people who had taken shelter in boathouses near the sea, died instantly as temperatures soared beyond 250 degrees Celsius. Their bodies were so perfectly preserved by the heat and ash that archaeologists 2,000 years later could read the final expressions on their faces, the last gestures of their hands. But Herculaneum was just the beginning. Over the next 9 hours, 6 massive pyroclastic surges would pour down from Vesuvius, each one more powerful than the last. The fourth surge finally reached Pompeii, traveling 25 kilometers from the volcano and slamming into the city with the force of a freight train made of molten rock and poisonous gas. Here we confront the brutal truth that even modern technology cannot overcome. There is no protective equipment that could allow a human being to survive direct contact with a pyroclastic flow. These phenomena reach temperatures of 1,000 degrees Celsius and speeds of 700 kilometers per hour. The most advanced heat-resistant suits worn by firefighters would be utterly inadequate against such conditions. Research into materials like aerogel, with its extremely low heat conductivity, offers theoretical possibilities, but the mechanical forces and toxic gases of pyroclastic flows create a zone of absolute lethality. Yet this harsh reality doesn't diminish the life-saving potential of modern science. It emphasizes that our greatest weapon against volcanic disasters isn't protection, but prevention through early warning and evacuation. Recent research from the University of Oxford has identified new methods for predicting volcanic eruptions using seismic anisotropy, the way earthquake waves split and change direction as they pass through stressed rock. Scientists can now detect changes in the Earth's internal structure that occur before explosive eruptions, providing even earlier warning signs. More dramatically, new infrasound monitoring systems can detect the acoustic signatures of pyroclastic flows the moment they begin and track their paths in real time. Imagine if the residents of Pompeii had received instant alerts on their mobile devices, not just when the eruption began, but precisely when and where the deadly flows would strike. Modern volcanologists can predict not just if a pyroclastic flow will occur, but where it will go, how fast it will travel, and which areas will be safe. The technology that could have saved Pompeii exists today in a constellation of monitoring systems that would seem like magic to ancient eyes. Satellites equipped with thermal sensors continuously monitor volcanic regions, detecting temperature changes that indicate rising magma weeks or months before eruptions occur. Synthetic aperture radar can measure ground deformation with millimeter precision, revealing the subtle swelling that occurs when underground magma chambers inflate. Networks of seismometers distinguish between the different types of earthquakes that herald volcanic activity versus normal tectonic movement. Chemical monitoring adds another layer of protection. Automated gas sensors measure concentrations of sulfur dioxide, carbon dioxide, and other volcanic emissions. Increasing sulfur dioxide levels are particularly diagnostic of accelerating volcanic unrest, as rising magma begins to heat and decompress, releasing dissolved gases. In Pompeii's case, such monitoring would have detected chemical changes in Vesuvius's breath years before the eruption, providing ample time for long-term planning and preparation. But technology alone wouldn't have been enough to save Pompeii. It would have required a social and communication revolution as well. Modern emergency management systems don't just detect disasters, they communicate warnings instantly across multiple channels. Automated alert systems send notifications via text messages, emails, and social media to authorities and the public simultaneously. Emergency broadcasts interrupt regular programming, while sirens and public address systems reach those without electronic devices. In 79 AD, news traveled at the speed of a running messenger. Today, warnings travel at the speed of light. The logistics of evacuation present their own challenges, but modern systems have transformed what once seemed impossible into routine emergency management. Current evacuation protocols use stage strategies, dividing threatened areas into zones that are evacuated sequentially based on their proximity to danger. Traffic management systems reverse highway lanes to create one-way corridors out of disaster areas, while GPS navigation updates routes in real time to avoid congestion and damaged infrastructure. Studies of urban mass transit evacuation demonstrate that properly coordinated systems can move large populations from confined spaces within hours. The 20,000 residents of ancient Pompeii represent a manageable evacuation challenge by modern standards, smaller than many routine evacuations conducted for hurricanes, floods, or other disasters. With 18 hours of warning from initial eruption to deadly pyroclastic flows, modern evacuation systems could have moved the entire population to safety multiple times over. The human factor remains crucial in any disaster response. Modern emergency management recognizes that technology alone is insufficient without community engagement and education. Regular evacuation drills ensure that populations know where to go and what to do when disasters strike. Public education campaigns build trust in scientific warnings and prevent the dangerous normalization of risk that plagued ancient Pompeii. Perhaps most importantly, modern volcano monitoring never stops. Unlike the Romans, who experienced Vesuvius's 17-year buildup without understanding its significance, today's monitoring networks maintain constant surveillance of dangerous volcanoes. The current monitoring of Mount Vesuvius involves extensive networks of seismic and gravitational sensors, GPS-based arrays measuring ground movement, and satellite-based radar systems tracking even minute changes in the mountain's shape. All of this data flows continuously to the Vesuvius Observatory, where scientists maintain round-the-clock vigil over the sleeping giant. This continuous monitoring has revealed crucial insights about how volcanoes behave before major eruptions. Long dormant volcanoes like Vesuvius show distinctive patterns when they begin to reawaken, patterns that would have been clearly visible in the decades leading up to 79 AD if monitoring systems had existed. Episodic seismic swarms, ground deformation, and changes in gas emissions create unmistakable signatures that modern science can read like a volcanic biography. Recent archaeological discoveries continue to reveal just how many warning signs the Romans missed. In 2023, archaeologists uncovered skeletons of two men in Pompeii who died not from pyroclastic flows, but from building collapse during earthquakes that occurred simultaneously with the eruption. One victim was found with his left hand raised, as if protecting his head from falling debris, a gesture that speaks across 2 millennia of human instinct in the face of disaster. These deaths were entirely preventable with modern earthquake-resistant construction and evacuation procedures. The broader implications extend far beyond ancient history. Today, Mount Vesuvius remains one of the world's most dangerous volcanoes, precisely because it sits in the most densely populated volcanic region on Earth. More than 3 million people live close enough to be affected by a future eruption, with at least 600,000 in the immediate danger zone. This modern population far exceeds ancient Pompeii, creating evacuation challenges that dwarf those faced by the Romans. Yet recent volcanic disasters demonstrate the life-saving power of modern monitoring and evacuation systems. The 2018 eruption of Kilauea in Hawaii, despite its destructive power and months-long duration, resulted in no direct casualties due to effective monitoring and evacuation. Scientists detected the precursor signs months in advance, tracked the eruption's evolution in real time, and coordinated evacuations that kept residents safely ahead of the destruction. Similarly, the ongoing monitoring of other dangerous volcanoes worldwide has prevented countless disasters through early warning systems. When Mount St. Helens reawakened in 2004 after years of dormancy, scientists detected the warning signs immediately and implemented monitoring systems that tracked every tremor and gas emission. Though the volcano ultimately produced only minor eruptions, the preparedness system stood ready to evacuate hundreds of thousands of people if necessary. The technology continues to evolve, promising even greater protection for future generations. Artificial intelligence systems now analyze vast amounts of seismic, thermal, and gas emission data simultaneously, identifying patterns that human scientists might miss. Machine learning algorithms can process information from multiple monitoring stations in real time, flagging anomalous activity with superhuman speed and precision. Unmanned aerial vehicles equipped with gas analyzers and thermal sensors provide real-time data from dangerous volcanic zones without risking human lives. These drone systems can fly directly over active volcanic vents, measuring temperatures and gas compositions that would be impossible to obtain safely through ground-based methods. Advanced materials research continues exploring theoretical possibilities for protecting people from extreme volcanic conditions, though these remain experimental. The real promise lies not in surviving volcanic disasters, but in predicting them so accurately that exposure becomes unnecessary. Future seismic early warning systems will integrate multiple technologies, including improved sensors, advanced signal processing using machine learning, and expanded global monitoring networks. Scientists envision a future where volcanic disasters are predicted days or weeks in advance, allowing for orderly evacuation of entire regions before any danger occurs. The transformation from Pompeii's helplessness to modern preparedness represents one of humanity's greatest scientific achievements. We have learned to read the Earth's warning signs, to understand the language of seismic waves and satellite data, to predict the unpredictable. The preserved streets of Pompeii serve as both monument to past tragedy and testimony to how far we've come. But perhaps the most profound lesson from Pompeii transcends technology entirely. The greatest disasters often result not from the raw power of natural forces, but from our failure to recognize and respond to their warning signs. The Romans had 17 years of increasingly urgent geological signals, yet they remained unprepared for the inevitable catastrophe. Modern science has given us the tools to avoid repeating their tragedy, but only if we maintain the wisdom to use those tools effectively. As we stand today in the shadow of active volcanoes around the world, we carry the responsibility of that knowledge. Every monitoring station, every satellite, every evacuation plan represents our promise to the ghosts of Pompeii that their sacrifice was not in vain. We have achieved what they could never imagine, the power to see disaster coming and the means to step aside. The story of Pompeii reminds us that while we cannot control the forces of nature, we can choose to be prepared. That choice, backed by the full power of modern science, makes all the difference between tragedy and survival. In the end, our greatest victory over the volcanic fury that destroyed an ancient city isn't that we can now survive pyroclastic flows. It's that we never have to face them in the first place. The lost city of Pompeii stands eternal, its people preserved in their final moments, their story echoing across time with a simple message. Listen when the earth whispers its warnings, because you don't want to be there when it screams. With modern science as our guide and ancient wisdom as our teacher, we finally possess the power to heed that warning. The question now is whether we have the wisdom to use it.